Okay. Hello everyone. Welcome to my channel and I hope I am audible. Okay. So in this video we are discussing about the problem of the day of the Leetcode, and basically it is named as bag of tokens, that is named as, like, it is numbered as 948, and it is a medium level question. So what the problem states, so basically uh, the problem statement is somewhat critical to understand. It's not very like you can understand in a very uh, initial stage. I also took a small while to understand it properly. So it is basically a very easy problem if you understand it. So basically what it is showing that you have an initial power of you are giving an integer value power, and you are given a initial score of 0 and a bag of tokens where token I is the value of the ith token, right? So it is basically an array, and your goal is to maximize your total score by potentially playing each token in any of the two ways. Okay, so basically we have two ways to play any token. So what it states that if your current power is at least token I, you may play the ith token face up and losing token I power and gaining one score. Pretty cool. And if your current score is at least one, you may play the ith token face down, gaining tokens I power and losing one score. So basically what it states that we have two conditions. I'm writing here. So suppose I am I can play as up. So what is the condition of playing up? So to play up, it is given that I have to lose my power by uh, like token of I, and my score will increment by one. And if I play by down power, so power will just increment by token of I, and my score will reduce, right? So we have understand this point, correct? Moving on ahead. So we are giving that each token may be played at most once and in any order. So we are given an array, so we can use any value of token I only once, right? So you do not have to play all the tokens. So basically, it is also given that it is not necessary that you have to execrate all the array, and so basically you can use any number of tokens as you want. So what the basic task, we have to return the largest possible score you can achieve after playing any number of tokens. So let me give you a brief what the problem is stating. So let me give you an example of this. I will try run on this and you will be able to understand. So we are given an array that is 100, 200, 300 and 400, right? And we are given a power of 200. So what we initially we have a score of 0, right? So we have to maximize this value, right? And basically what we are given, we have two basically choices. Either we have to play up or we have to play down. So if we play up, what is given is that our power will negotiate by token of I, but our score will increase. We have to increase our score, so it is fine. And to play in down, we have power incremented by token I, but our score will reduce. Pretty much cool. So what we were doing, we will try run on this. So basically, tell me one thing, right? Tell me one thing, that suppose if I am given an array, right? Suppose for take an example of this. So what I can do is that 100, I can take 100 because it is less than our power. So I can take 100 into my basically score. And what I will do, I will just uh, uh, take 100 and move on to the next index. I mean 200, I will move on. And what I will do, I will just decrease my power by 100. So it becomes 200 minus 100, it becomes 100. And the second point is that our score is initially 0 and now it will increase to 1, right? This is one condition that we are going. So what we have done is that we have played it upwards. Later I will make you understand what do you mean by upward and downward. So after that we will move on to the 200. Now here is the catch. Now we have 100 as power and we have 200 as our token height. So obviously we like can't take it because our power is less than it. So but we have to maximize our score. Like we have a score of 1, we have to maximize. So what we can do here is that so we have to take maximum number of tokens. You have to keep utilize maximum number of tokens upwards. We have to play maximum upwards token to increase our score, right? So what I can do is that if I take this 400, right, in my power, if I play downward now, and if I take 400 as my token of I, and just I and if I play downward, what it is going to do, my power is incremented by 100, like I have incremented, so it become 500, and my score will reduce, right? So now I have exhausted this value and this value. I have these two values left. Now I am on 200. So can I take 200? Absolutely yes. So my score will become 1 and my power will become 500 minus 200, that is 300. Now I have exhausted 200. Now I will move on to 300. Now can I take 300? Of course yes. So I will take 300. So my power is become 0, will become 0 and my score will become 2. So that's the basic idea. Like we have maximized our score by this operation. So how we will approach this problem? This is a basically idea. So we can think of a approach like two pointer approach. Let me just give you an hint. Like what I can do, what I'm doing is that whenever I am taking whenever I am playing upwards, like we have to decrement our power, so I am taking the smallest token always. Obviously, think greedily. So I am taking the smallest token so that my power does not affect too much. But when I am playing downward, I have to increment my power a huge bit so that I can accommodate a maximum number of upward token, right? So I am taking the maximum token to add in my power, right? So I am taking the maximum value that I am left with, right? So I'm taking the 400 value and I'm putting into the my power. So like what I'm doing is that whenever taking is playing upwards, so I'm taking the smallest token and decrement from the power, and I will increment my score. And when I'm playing downwards, I just take the maximum token I and add to my power, and I will decrement the score, right? So this is a basic approach, right? So how do we know that when we have to play upwards and downwards? So it's pretty normal. So basically what's the idea? You have to what's the code? You have to basically increment your score, right? So until and unless your power is smaller than the token I, right, you have to play upwards because we have to increment our score no matter we can play downwards or not, but we have to play upwards maximum time so that we can increment our score. So what's the condition? So to play upwards, our power that we are left with should be greater than equals to token of I, right? And at any we are playing that. If this conditions holds for all the tokens, we will just play upwards and we may not be using any downwards play, right? And when we play downwards, so when this condition does not hold true, we are moving to else part and we move play downwards, right? So I have this is a basic approach. Let me deep down into the code. The code is pretty much simple. So what I have done is that we are given a token array and power initially. So I have calculated the token size, and now to approach in a two pointer approach in this problem, I have to sort the given array. I have sorted, and I'm just taking two pointers. One is initially at zero index, and the other is at the end of the array. And I'm taking initially a score as zero, and maximum score that I have to return is at initially it is zero, right? Because the score I am changing it anytime, uh, maybe it upward and downwards. Later you will see in the code. But maxi basically accounts for the maximum number of score that I have, right? I can achieve, right? So this is basically a two-pointer approach part. So let me explain you. So I will play like while I is smaller than equals j. So the first condition for upwards. So if my power is greater than equals to token I will just increment my score, and I will as I have incremented my score, I will just update my maxi to the max of maxi comma score. And what I will do then, I will just decrement my power by token of I, and I will move I plus plus. I will move my I to next index, right? And this is a else condition that is pretty much logical. You can think like now you can't play upwards if you reach to this condition, right? So you will say like, what is the necessity of else if? You can just write it as else, but it is not the case. See, when uh, to play downward you should have a condition, because when you are playing downward you have to decrement your score, right? So you have a minimum of a score 1 to decrement, right? So you have a score of greater than 0 to play downward, of course, right? uh, Suppose, let me give an example. So suppose you have 12. I'm giving an example, just 13, 14, 15, right? This is an example. Tokens, and your power is 6. You are given a power of 6. So let tell me how you can, like, you can't play upwards, right? You can't play any times upward because you have a score of 0, and you can't take any of the, like, because the smallest value is 12. So how can you take, because your power is still smaller? So in this case our answer will be 0, because I to play downwards at least I have to play one time upwards, right? You understand it, right? So we are moving on to the else if condition. Score is greater than 0. I will just increment my power by tokens of j. I am taking the max value that j pointer is at the end, and I will decrement my score and decrement my j. And else condition, this is the else condition. If I do not reach any condition, like in this case, I will just break, because the smallest is still greater than the initial power. So I will just break, and I have my initial maxi as 0. I will just return a maxi there. And otherwise, if this conditions hold true, and if this while loop, like, come into action, I will have a updated maxi that I will return afterwards. So this is all about a question. So it is somewhat a small tricky part, and it is basically an easy question. So I hope you like that. So thank you very much, and let meet you in the next video. Bye bye.